Hi, my name is Jawad Hither and I'm lecturer at Pasban Online Academy. And in the previous video, I have discussed about the semiconductors and its types. What are their types, intrinsic and extrinsic, right? And in extrinsic semiconductors, we have discussed about the P and N type semiconductors, how they are formed by doping 3A and 5A elements with the pure semiconductors respectively. Now I am going to discuss about that when P and N type semiconductor are joined together, then what happened? Once they are joined together, the N type semiconductor have high energy, high electrons, right? The N type has saturation of electrons, while in P type there are saturation of holes, and once they are combined with each other, then there is a region where the electrons from N type and holes from P type semiconductor diffuse and they form a neutral region. That region is called depletion region, right? So depletion region is defined as a neutral region which is formed when electron from N type diffused with holes of P type material, right? Okay. Due to this depletion region, so first we are going to discuss when they are combined, what will happen. A new material or a new electrical component is formed. That name is diode, right? So diode has a P junction, N junction, and a depletion region in between P and N, right? So what does it do? Depletion region has some voltage. So for example, in the case of silicon, it's 0.7 volts, and in case of germanium, it's 0.3. Right? So now we are going to discuss that how it operates. First, we are going to know that how we can make it simple. So we make the P type region large with a line and form a triangle. The triangle direction is towards the N type, and we draw a line like that. Okay, so it's a P type and it's N type. Okay. Now we are going to discuss that how they operate. Okay, so there are two types of biasing which are being had for the case of diode, right? The first one is forward biased and the second one is reverse biased. Okay. For the case of forward bias, how we have to connect the diode? Let's see. Okay. Okay. So for the forward bias, we have to connect it. The P type semiconductor will be connected with the positive terminal of the battery, right? And the n-type semiconductor will be connected with the negative terminal. While sometimes in the papers you are not given like this positive and negative, you are just given like the small and the large line. So the large line is for positive terminal of the battery, it's DC, and the small line is for negative terminal of the battery. Okay, so this is the P junction, this is the N junction. Now what happens when it is connected in the forward bias direction? So the holes from the positive terminals of the battery come towards P junction. Okay, so there are already holes in the P junction. Okay, these holes repel that holes continuously, and these holes are going to diffuse with the electrons in the N region, right? Okay, and when electron moves from here, then the depletion region in this case, in the forward bias case, will be shrinked. Why it will be shrinked? Because the potential barrier is going to be small and small again and again, because it is connected in the forward bias direction. While in the case of reverse bias direction, how we connect it? We connect it just like that. The positive terminal of the battery is connected with the N-type semiconductor, while the negative of the battery is connected with the P-type semiconductor, and in this case the depletion region always increases up to a certain limit, right? And after that certain limit, the diode will be destroyed. The current move during that reverse bias is reverse current, and the maximum current moves during reverse bias is the maximum current moves during forward bias is saturation current. Now I have discussed the diode. The summary of this lecture is what are diode? When the P and N junctions are combined, P and N semiconductors are combined, there is a depletion region formed between them, and that depletion region shrinks once the we connect diode in the forward bias direction, right? And if we connect that diode in the reverse bias direction, that depletion region increases, right? And due to that, the potential barrier for the silicon is 0.7. But if we are going to connect it in the reverse bias direction, that potential barrier becomes so increased, then no electric current will pass through it. While in the forward bias direction, there is a current pass through the diode, right? That is IF, forward current, and in this case there is two small current pass through it, that is a reverse current, IR. So the graph of the forward bias is just like that. That is the knee voltage, okay, 0.7 volt. Okay, that is a knee voltage. And what is it? It is basically the potential barrier, right? And for the case of reverse bias direction, the graph will be just like that. This is reverse current, okay, and the voltage here will be VB. VB stands for breakdown voltage, and I R stand for reverse current. IF is for forward, and what about the VK is for knee voltage. That knee voltage is basically the potential barrier. Why it is called potential barrier? Because if we are not going to overcome that potential barrier, then no current will be passed through it, right? So there are three approximations for the case of diode. The first approximation is that there is no potential barrier. It means that the potential barrier is zero. Alright. So there are three approximations for the case of diode. Right? The first approximation is that there is no potential barrier there is no potential barrier. It means that Vk is equal to 0, so its graph will be like this. Okay, the first approximation is that there is no losses and there is no new voltage, there is